Okay, so I've had a lot of questions about what we're doing, and I don't know what to do, and I'm completely lost. And these are a lot of the questions that I'm receiving. We're talking about equations where x is squared. Okay, that's the first equation. Y equals x squared. It is a quadratic, guys. All quadratics are squared second degree. Remember, 2 means second degree. So for these quadratics, we simply need to know how to graph them. I think that's the very first thing you need to know how to do. Now, they're in a computer, it's different than on a piece of graph paper. But what you're going to do, if you were using a piece of graph paper, I'm pretending like this is graph paper, okay? And we're going to figure out whenever we have a value for x, what's the value for y? Y is equal to whenever x gets squared, okay? Now, if you look on this graph, I'm only picking the numbers between here and here on the x-axis, okay? This is 2, this is -2, I got 1 here, excuse me, -1, and then that's 1, and then there's 0. Those are the only numbers that I'm concerned with because that's where the curving takes place. The curving takes place, it comes from left to right, it curves down, and then it curves back up, and we just need to know some numbers that tell us that information. Now, if I put in 0 for x, the first number I'm going to pick, 0 squared is 0, therefore y equals 0. If I put in a 1, 1 squared is just going to be 1 because 1 times 1 is 1. And if I put in 2, 2 squared is 2 times 2 or 4. Now, when you square a negative, it becomes a negative times a negative, which gives us a positive. Same thing here, a negative times a negative, -2 times -2 is +4. Notice how this has some kind of pattern that you can see, 4, 1, 0, and then back 1, 4. So if I put 3 in here, 3 squared is going to be 9, which means if I put a -3 back up on top, I'm going to get 9 also because it fits the pattern, okay? And these are all just points on the graph. I can pick any x value I want because x is unlimited. You can pick whatever you want for the value of x, but whatever you pick for x, to figure out what y is going to be, you have to square it for this specific one. Again, we called this one the parent function, and everything else gets compared to this, okay? Now it becomes just a bunch of points that you plot on the graph. 0, 0, 1, 1, and 2, 4. Let's just do it. 0, 0, 1, 1, and 2, 4. Now, this thing has a line that cuts through. Ooh, erase that. This thing has a line that cuts through the center of this deal, and that is called the axis of symmetry, which is this guy right here, okay? This is the axis of symmetry. And if you can see, these points are also located on the opposite side of the axis of symmetry, almost the mirror image, and that's actually what it is. It's a mirror image of these two, and this thing is just a curve. And even though it doesn't look like it, it curves no matter where it's at on this graph, okay? That is a curve, and that is what a quadratic looks like. All other quadratics will be compared to that. And when we look at these things, we're going to be talking about when A is a different number, and then there also might be a B term and a C term. And they do things to this problem. They move this graph around, and that's what we're going to find out. This is just the intro.